Good afternoon or good day to every viewer. I have some questions on differential equation, and they are questions I extracted from 200 level pass questions of Olabisi Onabanjo University in Ogun State in Nigeria here. So I just stumbled on the past questions and I decided to have a shot at them. So this is one of them. Now, the current I in an electric circuit is given by Ri plus L di dt equals 0, where L and R are constants. Show that current I equals to capital I, which is the current at a particular time, exponential negative RT over L. Now, according to the knowledge of electricity, R is the resistance, I the current, L that is inductance, and T is time. So if you look at this equation given, it's a differential equation. So I'm going to rearrange so that it will look the normal form. That means L, this is solution, L di dt plus Ri is equal to 0. Okay. Now, we are asked to show, that means we want to prove that current small I is equal to capital current I multiplied by exponential negative RT over L. Okay, from here, in order to make it look in the form of a linear differential equation, I'm going to divide through by L. So dividing through by L, this L will cancel out here. I have di dt plus that same L will divide out, that will be R over Li equals to 0 because 0 over L is 0. Okay. Now, this is a form of linear differential equation of the form linear. This is the general format for a linear differential equation. dy dx plus py equals to q. So by the time you compare this format, any form of equation, differential equation that is of this type, we call it linear differential equation. Okay, dy dx can be likened to di dt. That means I is taking the place of y, t is taking the place of what? X. Then definitely I is taking this place of y. That means p will be r over l and q will be what? 0. Because according to linear differential equation, q can be a constant or a function of x under this format. That means q is a constant here, which is what? 0. Okay? Now, what do we do? Whenever we have a differential equation, how do we go about it? We look for the integrating factor. Integrating factor. Integrating factor is e to integral of p dx, which in this case will be p di. That means because will be p dt in this case. So that means let me write p dt because we are differentiating, we are integrating rather with respect to what? To t. Okay? So this is our integrating factor. That means I'm going to find the integral of p dt now. Since p is equal to r over l and q is equal to 0. Okay, integral of p dt means integral r over l dt. And when we integrate this, since r and l are constants according to the information given, that means the result will be rt over what? L plus what? Plus c. But we will not name this what? This constant here. Why? Now, because we are finding integrating factor, which is exponential integral of this. That means integrating factor will be e to RT over L. That is our integrating factor. So, having gotten your integrating factor, what next? You find the complete solution. Complete solution is y times integrating factor equals to integral of integrating factor times q dt. I mean dx, because I'm using y here. That means the moment I change this y to what? I, according to this question, this one will change to what? dt. Alright. Now, what next? I will bring in the result. That means I times e to RT over L equals to integral e to RT over L times 0 dt. So the whole of this will be 0 because 0 times this is 0. So that means if you integrate, that means we are going to have I e to RT over L is equal to integral of 0. And integral of 0 being a constant is what? Is a constant. When you integrate 0 is a constant. So that means we have I e to RT over L equals to what? C. Now, we are given the boundary value that when t is 0, small I will become capital I. So I'm going to put 0 to replace t here. Why this I will become capital I? That means I e to r into bracket 0 over L is equal to C. This will be e to 0 because 0 times this will be 0. And n to the power 0 is 1. That means C is equal to what? Capital I. So since E is equal to capital I, so what do we do? Definitely, so that means we come back here now. That means I e to RT over L is equal to capital I because capital I is replacing what? C now. So having done that, excuse me, we now make I destructive because what we are proving says small I is equal to capital I e to negative RT over L. So that means I dividing both sides by exponential RT over L, I will be equal to capital I over e to RT over L. So if you write this in the index form, it will be I e to negative RT over L, which is what we are asked to show. So this is the end of it.